This will be a tutorial on the two proportion z-test using Excel 2016. We're going to look at whether the proportion of Mac users differs across gender. So we have two categorical variables that are both dichotomous. A success in this case is observing someone who chooses to use a MacBook computer versus some other type of computing device. And we're going to compare whether or not that proportion differs across males and females. So I'm going to copy and paste my variables into a new worksheet. And the next thing that I'm going to do is I'm going to get the frequency of all possible outcomes. I'm going to construct a contingency table. So I'm going to insert pivot table. I'm going to select my two variables, columns A and columns B. And I'm going to tell Excel to put it in the existing worksheet in a cell that is open and has some space around it. So now in order to construct my pivot table, I'm going to select gender. I'm going to put it in the rows. I could have easily put it in columns, but I just chose to put it in the rows. I'm going to put computer. I'm going to put it in the columns. And now I have to tell it to give me a count. I want it the frequency of all these possible outcomes. So it doesn't matter which of these two variables I select. I'm going to select gender. I'm going to say click and drag it into values. And now what I have here is I have a two-way table, otherwise known as a contingency table, which gives me the frequency of all possible outcomes. A couple of things I don't like about this. I don't like these blanks here. So if you click the drop down arrow and you deselect blank, that will get rid of the blanks. Now what I really need to concern myself with are the proportion of successes within each group. The success in this case is someone using a MacBook computer, and our group is gender, male and female. So I'm going to look at the successes in those who identify as male. And if we look here, there were 21 people who chose to use a MacBook computer who identified as male. There were a total of 32 people who identified as male. Successes for female were 46 chose to use a MacBook computer out of the 58 total people who identified as a female. Now that we have the total number of successes in each group, what we're going to calculate next is the proportion of successes for each group. I'm going to calculate a p-hat for males, and I'm going to do so by taking the number of successes, 21. There were 21 MacBook users, and I'm going to divide it by 32 people who identified as a male. I'm going to do something very similar. I'm going to get a p-hat for females, and again I'm going to take the number of successes. 46 females chose to use a MacBook computer out of the 58 females that were surveyed. So we have a p-hat for each of our particular groups. Now, when doing the two proportion z-test, what we also need to calculate is something called p-hat pooled, where we pool our successes and pool our overall sample size. So I'm going to calculate p-hat pooled. And the way we calculate p-hat pooled is we take the total number of successes, so we have 21 plus 46, and we divide it by the overall sample size. How many people were overall surveyed? So we have 32 plus 58. And this will get me p-hat pooled. Now, another thing that I'm going to need later on is I'm going to need q-hat pooled, which is basically the complement of p-hat pooled. It's simply 1 minus p-hat pooled. We refer to it as q-hat pooled. This is simply 1 minus what we just calculated as p-hat pooled. So there we go. Now that we have p-hat and q-hat pooled, what I then need to calculate is the standard deviation pooled. Standard deviation pooled. Now, what we need is we need the square root. And what we're going to do is we're going to take the product of p hat pooled, multiply it times q hat pooled, and then we're going to multiply that times the sum of 1 over each respective sample size. So I'm going to take 1 divided by the number of total males, which was 32, plus 1 divided by the number of those who identified as female, 58. And be sure that all your parentheses align. So we have q hat pooled and p hat pooled. We have 1 over the total sample size of males plus 1 over the total sample size of females. And that will get us standard deviation pooled. So now that we have all that information, what we can then calculate is our z-score. Now, our z-score is just going to be the differences in our p hats. So the p hat for males and the p hat for females. Order of subtraction does not matter, just be sure to be consistent. So I'm going to do p hat males minus p hat females, and then I'm going to divide it by standard deviation pooled. Now we have our z-score. Once we have our z-score, we can then calculate a set of p-values. Now, our p-values are dependent on the type of alternative we have. Now, there are 3 versions of a type of test we could have. We could have a one-sided test, which is greater than. We could have a one-sided test which is less than. Or we could have a two-sided test, i.e. not equal to. So for each of these, they'll have a respective null. Now, remember, in the null hypothesis, we always assume that there is no difference between these two groups. So if there is no difference between them, numerically, that's represented as a 0. So keep that in mind. So what we're looking for here is, we want to know, well, what is the probability that we get a z-score that is greater than negative 1.4, negative 1.42. So in order to calculate the p-value, what we will use is, we will use the norm.s.dst. This is the standard normal distribution. We will plug in the z-score here. We will type in true. Now keep in mind, Excel will only give you left-hand probabilities. So what this will return once we hit enter is the probability of being less than negative 1.42. However, that is not what we want for this particular question. We want a one-sided greater than. So the easy fix there is before the norm and after the equal sign, simply type in 1 minus. This will give us the probability that we get a z-score that is at least negative 1.42. And notice we get a p-value of 0.923. Very large p-value, much greater than 0.05. We could also get a z-critical. Here we would use equals norm.s.inv. Now remember, we want the upper 5%. Why 5%? Because our significance level is assumed to be 5%. But Excel only gives us the left-hand probabilities. So the upper 5% is the same as the lower 95%. So our critical value is 1.645. Notice that our z-score of negative 1.42 is not greater or does not exceed our z-critical of 1.645. So our decision for this particular test for a one-sided greater than alternative would be fail to reject, meaning that there is no evidence of a difference in proportion of MAC users of males versus females. Here, for a one-sided test less than, again, the null hypothesis is we're always going to assume no difference. So the proportion of MAC users for males is the same as the proportion of MAC users for females. So our p-value is going to be calculated very similarly. We're going to use the norm.s.dst function again, the standard normal distribution. My z-score does not change. and I'm going to comma true. Now this will report the p-value that is strictly less than negative 1.42. And that's exactly what we want. For this particular test, we have a one-sided test where our alternative is less than. So we hit enter, and we get a p-value of 0.077. Again, this p-value is also greater than 0.05. We could also calculate a critical value. We would do equals norm.s.inv, and we're looking for the bottom 5% because our hypothesis or alternative hypothesis is less than to the left. And so we want the bottom 5%, and this will give us the z-score that bounds the lower 5% of the distribution, negative 1.645. And again, comparing our z-score of negative 1.42, that does not exceed the z-critical of negative 1.645. So our decision for this particular test would be fail to reject. And then finally for the two-sided test. Again, our null hasn't changed. That's still going to be 0. We always assume that there is no difference in the proportion of Mac users for males when compared to the proportion of Mac users for females. So our p-value is going to be the probability that we get something that is less than negative 1.42 or the probability that we get something greater than positive 1.42. Because of the symmetry of the normal distribution, all we simply have to do is take this p-value and multiply it by 2. Remember, this p-value here represents the probability of being less than negative 1.42. That will be the exact same as the probability of being greater than positive 1.42. So we can do 2 times norm.s.dst. We can select our z-score. That norm.s.dst will give us the probability of being less than negative 1.42, but we also will have to account for being greater than positive 1.42, which is where the 2 times comes into play. And notice this is indeed double that, which makes sense. The z-critical, again, we will have 2 because we have 2 tails that we are concerned with. It's a two-sided test. So we'll have the lower 2.5%. If our significance level is 0.05, we have to evenly distribute the significance level in the lower end of the distribution and the upper end of the distribution. So we will do equals norm.s.inv. And what I want here is I want the lower 2.5%. And this will give me a critical value of negative 1.96. I could also do a critical value for the upper 2.5% because it's a two-tailed test. I will have 2 critical values. It will be the same exact value except positive because of symmetry. The only thing that changes here is that if I want the upper 2.5%, remember Excel only reports the left-hand probabilities, so the upper 2.5% is the same as the lower 97.5%, so 0.975. Again, the same exact number except positive. And for our decision, notice that our critical value of negative 1.96 is larger than our z-score, or another way you can think about that is our z-score does not exceed negative 1.96 or positive 1.96. It falls in between that. So our decision is fail to reject, concluding that there is no evidence of a difference between the proportion of Mac users of males compared to females.